Hello, everybody. Welcome to Chem 1115, Chemistry and Society. And we are talking about Chapter 11. So this is the mini lecture for Chapter 11 from our textbook. And so, as always, I'm encouraging you to also read the textbook go along with the notes packet and this lecture discussion. So, we're now in the last unit of our semester. Chapter 11, 12, and 13 are the last chapters that we'll cover. So in chapter 11, we're talking about nutrition. And here are some guiding questions to get us started. What's in food? What are their effects on our health? What can we learn about food labels? How is our food supply? All that good stuff. So here's a reflection for you to do on your own. So we're going to skip over that. Let's talk about what a calorie is. I know everybody's heard this word before, and what it means to a chemist versus what it means out in society have two different meanings. So a calorie with a little c is the amount of energy that we need to use to raise the temperature of 1 gram of water by 1 degree Celsius. So that's not a ton of energy. So when we're talking about calories in a food context, we're actually talking about kilocalories. Okay, so that means 1,000 of the little calories. So one food calorie has an uppercase C, whereas a calorie, the little amount of energy that we take to increase the temperature of 1 gram of water by 1 degree Celsius, that's got a lowercase c. So that's how you tell the difference between food calorie, uppercase C, and energy unit calorie to a chemist, lowercase c. All right, some vocab words. Let's differentiate between malnutrition and undernourishment. Malnutrition is when your diet doesn't have the right amount of nutrients, even though your energy content might be enough. So if you eat nothing but, snack cakes all day, that would be malnutrition. You'd have enough calories, but you wouldn't have the appropriate mix of nutrients. Undernourishment is when your calories are insufficient to meet your metabolic needs. And so this is where I think probably everyone can say they've seen at least one of these at some point in their life. And again, it's uppercase C, calories. If you ever wondered why that C is capitalized, it isn't just to have good grammar. It's also because uppercase C, calories, refers to kilocalories. And so here is the breakdown. Your textbook gave this of some percents for some foods: percent water, fat, carbohydrate, and protein. I'm not going to make you memorize this. I think these are things you can read over on your own, but it is interesting because here's the composition of our body. And again, I've mentioned this in the past. A lot of people think, oh, if I'm 56% water, that means I've got this big lake in my body somewhere. Well, that's not exactly true. That means it's referring to that if you broke your body up into all its molecules, 56% of it would be water molecules. Okay, let's talk about fats and oils. These are some of the properties you're probably familiar with. They're slippery, they're slimy, they're greasy. They have a low melting point, and they cannot dissolve in water. So, all of the things that you think of when you think about fats: butter, cheese, cream, milk, meat, fish, right? And then also margarine and some of the shortenings are fats that come of vegetable origin, And so when we're talking about oils, we're talking about olive oil, corn oil, or nut oil, canola oil, which is a type of corn oil. All those oils are liquid phase. So here's an important vocab word for you. It's called a fatty acid. And a fatty acid is a long hydrocarbon chain. So it's a chain made out of carbons and hydrogens attached to a carboxylic acid, which is a type of acid. And for us here in world of chemistry, in chemistry and society, that's all we need to know about fatty acids. They have long chains that are made out of carbon and hydrogen, and then they have an acid at the top, which means they can act like an acid, and they can also act like an oil or a fat. And here's a figure if you want to look at it. If you take biochemistry or other courses, you'll study fatty acids in significantly greater detail, but that's all you need to worry about for chemistry and society. So here's an important definition, and I know you've heard these words before: saturated fat versus unsaturated fat. You probably heard that in discussions about dieting or nutrition or whatever. So a saturated fat contains all carbon-carbon bonds. So if we go back to this here, all of these carbon bonds are single bonds, okay, in a saturated fat. Whereas in an unsaturated fat, you have at least one carbon-carbon double bond. So this notation here is just called line notation. It's a way organic chemistry represents molecules, so you don't have to write out all the carbons and hydrogens. And so you can tell if there's a double bond in there because it makes a flat spot. And so if it's all single bonds, it would just look like zigzag, saturated fat. If it's unsaturated, there would be some double bonds in there, which put these flat spots, look like a little plateau. And so because you've got no flat spots versus flat spots, you have a big impact on the physical properties. So the boiling point, the melting point, all that stuff. So when we're talking about saturated and unsaturated fats, we're saying we're also looking at their physical properties. Saturated fats are the storage molecules for animals. Okay, so when you store your fat in your body, or when you're talking about any other animal, they're storing it as saturated fats. And they are solid at room temperature, whereas unsaturated fats are liquids at room temperature. So that's important. We don't store our fats as unsaturated fats. Those would be liquids at room temperature. Now, we do make some unsaturated fats in the form of oils because our body can manufacture oils. I mean, if you've got oily skin, just rub your nose right now. And there's some oil that your body has manufactured. But in terms of energy storage, we store our energy as fat. But our body does manufacture oils, and those oils would be unsaturated. So this is just some comparison of the fatty acids and looking at the length of the chain and the melting point. It's really all that this is showing for us in this class, at least. Like I just said, our body can synthesize any of the fatty acids we need. There are only a couple that we cannot synthesize ourselves, and so we have to get those from our diet. And anything that we can't synthesize ourselves is called an essential. So if you talk about an essential oil, that's something that our body cannot manufacture on its own through biochemical processes and have to get it from our diet. So that's where the phrase essential oil. And I know that's got a whole different meaning when you're talking about oils and homeopathy and all that good stuff. But for us as a chemist, we say something is essential. An essential amino acid is the same thing. It's an amino acid that our body can't manufacture, and you have to get it from your diet. All right, here's another word that you need to be familiar with. It's called hydrogenation. So if you have a unsaturated fat, because it's got those double bonds, and you want to make it into a saturated fat, you hydrogenate it. So you add hydrogen, the gas, with a catalyst and a metal, which we don't care about in this class, but it creates a chemical change, right? Because you're taking that double bond and you're turning it back into a single bond. And again, when the properties, when the bonding changes, the physical properties change. So that means that you can have something with a double bond and you make it into a single bond, and now you've changed the melting point, you've changed the softness, you've changed the spreadability. So for instance, think about margarine versus butter. Butter, saturated fat. Margarine, taken an oil and turn it into a saturated fat. But now you've made it, because of the properties of the oil, you've made it more spreadable. And then some other words that you've heard in the diet community: trans fats. Have you ever heard about trans fats? So in a trans unsaturated fat, okay, what that means is that the hydrogen atoms are on opposite sides of the double bond. And so those are typically called the bad fats, right? Because they've raised triglyceride levels in the blood, and it's a whole different molecular shape. Whereas you don't hear too much about these, the cis unsaturated fats have the hydrogen atoms on the same side. And I'm using the nomenclature that your book uses. Again, if you go on to take biochemistry or even maybe in just your basic biology class, you'll learn a lot more about these types of molecules. But right now, this is just all we need for a survey level course. Okay, carbohydrates contain carbon, hydrogen, and oxygen, hence the name. And they can be either monosaccharides or disaccharides. So what does that mean? Monosaccharides are just one single sugar, one single ring, excuse me. And a mono means one, poly means many. So a polysaccharide is made up of multiple monosaccharides. So polymer, monomer. Now that's just two of them, but if they can link up in big long chains, and that would also be a polysaccharide. All right, proteins, as we discussed in a previous chapter, proteins are polymers too. They're made up of amino acids. Those are the monomers there. Proteins are essential to all living cells. Okay, they're major components of your hair and your skin and your muscle. And that's usually what people think of when they think of protein. They're like, oh yeah, I need to eat a big steak. That's protein. But proteins are a part of every cell. So even if you're eating a salad, you're ingesting some protein because that salad, those leaves, have protein inside them. They transport nutrients through the cell. They do jobs within the cell. I had a nice debate with my 9-year-old about whether or not a salad has protein. And the answer is yes. It's not got the same amount of protein as a steak. You're right. But all living cells have protein in them because they have jobs inside the cell. They act as messengers, they're enzymes, they do a lot of stuff. So protein does not necessarily equal steak. It means they are big macromolecules made out of amino acids. And a mineral is either an ion or an inorganic compound. And those are things that you need for good health. So, a lot of people think that you've got metals in your body. Well, that's true, you do, but they're ions. Okay, so for instance, in the middle of each hemoglobin atom in your blood, you do have iron. Yes, that's why your blood smells and tastes metallic, because there is an iron in there. However, it's iron cation. Just keep that in mind. All right, so here are some figures from your book about estimated calorie levels for certain age groups. And here's how much energy it would take. Again, figure from your textbook, just to help put into context. All right, quickly talking about food safety. It comes from ingesting bacteria, viruses, parasites, and toxins. And these are the ways that we look for keeping those out of food. And then your book also talks about just the requirements for food production. Okay, just to make food. This should make you more aware before you throw something away. I'm always harping at my kids, eat your food, because there was a lot of effort that went into making it. It wasn't just me cooking it that was a lot of effort. That's true. But there was a lot of effort just to get it to my house, just to get it to the grocery store. Right? There were pumping energy requirements. Pollution was produced in making that food. Land was used in making that food. So before you throw away some trash, before you skip your dinner and throw it all in the trash, just be mindful of the fact that there was a lot of cost that went into that, other than what you spent for that month for that food. So here is a figure from your book about the amount of land required to produce different things. And here's a figure from your book about how much carbon dioxide is produced from certain types of foods. And so again, just for me to harp as a mother, because I'm a mom and that's just what we moms do, right? Don't just waste your food. And then food security deals with these issues. Is it available? Is it accessible? And then is it able to be used? So that's where we're going to stop for chapter 11. As always, if you have any questions, please feel free to reach out to me, and have a good day. Bye.